When you divide decimals by whole numbers, it's very similar in process to dividing whole numbers. So first thing we need to know is how to set up this problem correctly into a long division form in order to follow the long division steps. So this is 4 and 92/100ths divided by 2. The 2 is the dividend, that's the number we're dividing by, so it goes on the outside of the bracket. 4 and 92/100ths is the number we are dividing, so that goes inside the bracket. Then all we do is bring the decimal point up and follow long division steps. 2 goes into 4 2 times. 2 times 2 is 4. We subtract, we have no remainder to compare, so we bring down. 2 into 9 is 4. 4 times 2 is 8. We subtract, we have a remainder of 1, which is less than the divisor, so we can bring down. 2 into 12 is 6. 6 times 2 is 12, with no remainder. To check these problems, you can do like you did with whole numbers. You multiply the divisor times the quotient. So we're going to multiply 2 times 2 and 46/100ths. And in doing that, we count our decimal places. There are 2 decimal places in the factors, 2 decimal places in the product, and it matches the dividend. So the problem is correct. Now moving on to our next example. This is 3 and 96/100ths divided by 12. We're dividing by 12, so 12 is the divisor. 3 and 96/100ths is the dividend. It goes inside the bracket. We bring the decimal point up, and now we're ready to divide. 12 does not go into 3, but 12 goes into 39 3 times. 3 times 12 is 36. When we subtract, we get a remainder of 3, which is less than the divisor of 12, so we can bring down the 6. 12 goes into 36 3 times. 3 times 12 is 36. So our answer is 33/100ths. Now both of those examples, after bringing down the last digit and dividing, there was no remainder. So we see in this example, 42 and 1/10 divided by 5. We'll bring the decimal point up, and we're going to notice that there will be a remainder at the end. So we'll see what to do in that case. 5 cannot fit into 4, but 5 goes into 42 8 times. 8 times 5 is 40. I subtract. I compare. The remainder is less than the divisor, so I bring down the 1. 5 into 21 goes 4 times. 4 times 5 is 20. I get a remainder of 1, which when I check or compare again, it's less than the divisor 5. But I can't put a remainder back here behind a decimal number. So we have learned that we can add zeros behind the last decimal places without changing the value of the number. So I can add a 0 here in this dividend, and I'm still not changing the value of 4 and 42 and 1/10. It's just now becoming 42 and 10/100ths. Bring the 0 down and divide 5 into 10. It's 2. 2 times 5 is 10. And we've worked the remainder into that hundredths place. So the remainder, in essence, goes away. In this problem, let's see, our problem starts off as 8 into 84. So we divide 8 into 8 as 1. There's no remainder, so we bring down the 4. 8 does not go into 4, so that would be 0. Now, if you follow through and do this step, even though this part that I just did is optional, you don't really have to do that, but you still get a remainder of 4, which is less than the divisor. So we can't leave a remainder anymore. So what we're going to do, instead of just adding a 0 like we did in the other problems, because that would give us 840, we couldn't do that, we're going to add a decimal and a 0. That way the dividend still has a value of 84, but we have another 0, another place that we can bring this 0 down and divide. But let's bring the decimal point up so we don't forget it before we bring the 0 down to divide. 8 into 40 is 5. 5 times 8 is 40. So again, we've worked the remainder into the quotient. In the next example, 3 divided by 4. You have to remember, the number we divide by is the divisor. That goes on the outside of the bracket. The number we're dividing goes inside the bracket. So now we try to divide 4 into 3 and it doesn't go. So just like on the previous problem, we can't just add a 0 because 3 would become 30, but we can add a decimal 0 and still keep the dividend with a value of 3. So we bring the decimal point up and we divide. 4 into 30 goes 7 times. 7 times 4 is 28. We subtract and we get a remainder. This remainder 2 is less than the divisor, but we can't leave a remainder. So we're going to add another 0 into the dividend, bring it down, and divide again. 4 into 20 goes 5 times. 5 times 4 is 20. If we have a problem like 1 divided by 8, the 8 is the dividend, the 8 is the divisor, and 1 is the dividend. 8 doesn't go into 1, so we're going to add a decimal and 0. 8 goes into 10 one time, and we still get a remainder of 2, which is less than the divisor, so we add another 0 and bring it down. 8 goes into 20 2 times. 2 times 8 is 16. So we get a remainder of 4, which is less than the divisor, but we still have a remainder. So sometimes we have to add more zeros in order to get rid of the remainder. But we'll do that until either the remainder goes away, or unless we've seen an example like this one, where it would be 3 into 1 when we set it up. We add a decimal and 0, and we divide 3 into 10 is 3. And as we continue working this problem, we're going to notice that it just keeps repeating. So in that case, we just know that our quotient is going to be a repeating decimal. So we're going to put 3/10 with a bar over it to show that the 3 repeats. So this is how we would show our answer. You can put a 0 in front if you want to mark that space with a 0, but that's optional. But the bar goes over the 3 to show that it repeats. Here in these problems, we're going to divide 4 into 32 6/10. And when we go through the division steps, we're going to get to this point and we're going to have a remainder. Now as a reminder, this problem already had a decimal in it to start with, so we don't add another decimal, we just add the 0 and bring that down. And divide 4 into 20 is 5, and the remainder goes away.